In this video, we will discuss gas density and a helpful formula to solve for density or molar mass of a gas. So, if you remember from very first unit of chemistry, density is equal to mass divided by volume. And the units that we like for mass would be grams. And since we're in the gases unit, the unit for volume that we like would be liters, and that's going to make the math nice. If we're going to use this formula, we need to make sure our mass is in grams and our volume is in liters. And the formula is molar mass equals density times gas constant R times temperature in Kelvin divided by pressure in atmospheres. And so that's going to be a way to remember that is that molar mass kitty cat. All good cats put dirt or density, gas constant, temperature over their P or pressure. Okay, so let's just see how this works. And remember, when we solve for molar mass is going to be in units of grams divided by moles. So in example problem number 1, it says the density of a gas was measured at 1.5 atmospheres and 27 degrees Celsius and found to be 1.95 grams per liter. Calculate the molar mass of the gas and then also identify the gas. So molar mass equals dirt over P, and we are solving for molar mass. The density, 1.95 grams per liter, that is in good units, so 1.95 grams divided by liters. Gas constant is 0.0821 atms times liters divided by moles times Kelvin. The temperature is 27 degrees Celsius or 300 K. And then the pressure is 1.50 atms. And when I solve this out, my molar mass is 32.019 grams per mole. Looking at the periodic table, some people might see that this is in fact oxygen. Okay, some people will say sulfur because sulfur is 32.06, but it could not be sulfur because sulfur is not a gas at 27 degrees Celsius, so it's most likely oxygen. Okay, we will do one more problem and then we'll call it a day on this set of notes. Is that we've got some sort of formula of silicane where we've got some number of silicon atoms, and then the hydrogen atoms are found by taking the number of silicon atoms, multiply it by 2, and then add 2 to it. This is a little bit of some organic chemistry here. And we've got a density of 5.47 grams per liter. We're at 0 degrees Celsius, which is 273 Kelvin, and 1 atmosphere. And we want to determine the formula. So the best way to do that is that molar mass equals dirt over P, because molar mass gives us the identity of the formula in a way without giving us the direct formula. Because let's say I get a number for a molar mass that's 18.02. Well, water pretty much is 18.02 and nothing else. So that's why molar mass is so helpful for us. If I plug in 5.47 grams per liter, 0.0821 atms times liters divided by moles times Kelvin, we are at 273 Kelvin, and then I'm going to divide that by 1 atm, and that's going to give me the molar mass. And when I solve for molar mass, that's going to be 122.60 grams per mole. But that doesn't answer the question. It says determine the formula. So here's how I'm going to do this. Is silicon, just Si, is 28.09 grams per mole according to the periodic table. So if I can figure out how many silicons can go in here, the rest of the mass is probably just hydrogen, because hydrogen is not going to really contribute all that much. So I'm going to take 122.60 grams per mole, and I'm going to divide it by 28.09 grams per mole. And when I do that, I get 4.36. So that means my silicon is going to be 4. And then if I look at my formula for hydrogens, 2n plus 2. Well, n is now 4, so 2 times 4 is 8, plus 2 would be 10. So H10, and let's check if this works out. This molar mass, when I plug it into my periodic table, is 122.46 grams per mole, and that's within the range of air, we can say, so that looks good.